Okay, for number 19, we are going to be starting with f of g of x, which can be written as f of g of x, if you like. And then I'm going to get my f function ready to substitute in g of x. So my f of x function is 2x plus 1. And my g of x function, which is going to go in for all the x's of f, is the square root of x. And when I write that and clean it up, I can just write it as 2 square root of x plus 1. And that's it for the composite function. And then I'm going to find the domain of my composite function itself. And when I look at my composite function, I see that there's a square root in there, and I have to figure out where my square root is not negative, which would be greater than or equal to 0. And when I set the radicand of x greater than or equal to 0, it's already solved for. Also, I have to inspect just g of x by itself, and g of x is just the square root of x. So again, I'm just taking the x, setting it greater than or equal to 0, and the domain of my inner function happens to be exactly the same as the whole entire composite function. For the whole entire composite function, you only have to worry about that square root of x, and for the inner function itself, you are just worried about the square root of x. And so the overall domain is of f of g is from 0 to infinity. So anything that is greater than or equal to 0. 0 to infinity. Now we're going to do g of f. And g of f of x is equivalent to g with f of x plugged inside of it or subbed inside of it. I'm going to get g ready, and g is the square root of x. And my f of x function is 2x plus 1. And so I'm going to look at my composite function here, and I see that I have a square root in my composite function, and I need to figure out what makes that radicand underneath non-negative. So I'm going to take my radicand of 2x plus 1 and set it greater than or equal to 0. And I guess I just forgot to clean this up. I would just end up taking off those parentheses and write it as 2x plus 1. There's your final composite. Okay, so back to domain. So I'm going to figure out the domain of the entire composite function and set my radicand greater than or equal to 0. I get 2x is greater than or equal to negative 1, and x is greater than or equal to negative 1/2. And then I'm going to look at my inner function in blue and see if there are any additional domain restrictions just from that piece. And I can see that it's just a regular polynomial without any fractions or square roots in there. And so it's all real numbers for the domain of f of x, and I have no additional restrictions. So the domain of g of f is going to be from negative 1/2 to infinity, anything greater than or equal to negative 1/2, and that looks like this, negative 1/2 to infinity.